Okay, so yeah, when we are we're going to talk here a little bit about counting, and which might sound, that sounds easy, but the idea is, all right, so if I have something, I want to know how many ways a certain thing could happen. For example, if I flip 10 coins, how many different possibilities are there, or something like that, and we'll work our way up to bigger things like that. But one of the techniques for counting is you might call it the brute force method. It's just by listing everything out. So we're going to talk about several different methods, but the first one is just by listing. Okay, we can count the ways something can occur just by listing it out. So the listing method is the first way we'll do this. Figure out how many ways something could occur. All right, so like I said, we'll talk about bigger things later, things that have more parts, but let's just talk about, all right, so how many possibilities are there if, number one, we flip two coins. So yeah, sometimes we're just interested in how many ways can an event occur. This is a good example to start with here. Flip two coins, how many possibilities are there? So we're just going to list these out. And so we could have them, we flip two coins, we could have them both turn heads, come up heads, we could have them both turn up tails, or we could have one heads, one tails. Now, the thing on that is when we list them out like this, there is a distinction being made here between the coins. So coin one is heads, coin two is heads, and coin one is tails, and coin two is tails. And that's really significant here because this is coin one heads, coin two tails. So what else could there be? You could have tails heads, right? That'd be different because there's two different coins, okay? A dime and a nickel, or nickel and a quarter, whatever, but there's a distinction between, so that's a little bit different than, we've talked about sets a little bit. And in sets, the order didn't matter, but in this particular case it does because, like I said, two different coins. That's it, isn't it? Right? So there's four possibilities. So that's one way of doing this. Just list them all out. All right, now, let's see. How many possibilities are there if we flip three coins? Well, again, one way is just to list them all out. We could have, now, this is a good point to talk about this. If we, there's, some events have more things, some things have more possibilities, and so it's usually a good idea to kind of come up with a system. Your system doesn't have to be the same as my system or the other person's system, but if you kind of do it in a system, here we could do, like here we could have all heads. So we've got three heads. Then we could say, well, we could have two heads and one tail. So heads, heads, tails. But, right, there's more possibilities with two heads and one tail, right? Because we know there's three different coins here. We're distinguishing between them. So how else could I have two heads and one tail? Well, I could do heads, tails, heads, right? The tail's in the middle. Or the tail's on the first one, tails, heads, heads. Okay, so gives me 2 heads and 1 tail, the possibilities there. What else could I have? 2 tails, 1 head, right? That would be different. So I could have tails, tails, heads, but there's different possibilities there because you could do the tails, then the heads, then the tails, or you could do the heads first and then the 2 tails. And you don't have to necessarily list them in this order, but just kind of a systematic way of doing this is going to be our theme here for a little bit. Or what else? What else could there be?
All tails?
All tails, yes. So all tails would be a possibility. Are there any others? I don't think so because I've got 3 heads, no tails. I've got 2 heads, 1 tail. I've got 2 tails, 1 head. And I've got all 3 tails and no head. So that pretty much covers it. So that's one reason for doing a system is you kind of know you got them all listed out there. Now this is also, so there's 8 possibilities. Now, this is also a good place to also tell you about another possible way of listing these out, and we'll use this in an example later on to help us. But it's called a tree diagram. And this will be our tree diagram for 3 coins, so we're just going to redo this one and confirm it, I guess. But on a tree diagram, what you do is it's sort of a column, I guess, but not really. But for each part, you kind of separate it kind of out like this. So in this case, we've got 3 coins. So the first coin is going to go here, the second coin is going to go here, the third coin is going to go here, and then our last part over here will be our outcomes. But here's how it works. We start with the first coin, and so you can have heads or tails on it. Now, I would spread these out a little bit because what we're going to do, the reason it's called a tree diagram, is then you branch off of that. So, if the first coin is heads, then our second coin either could go heads or tails, right? So we branch off of that first coin, heads, to heads or tails on the second coin. Well, we can do the same thing on the tails for the first coin. The first coin, we could branch off then to the second coin to be heads or tails there. All right? Now guess what we do? Well, if the first coin's heads, the second coin is heads, then what could the third coin possibly be? Well, it could be heads or tails again. And same thing for all those, right? If the second coin is tails, the first coin's heads, the second coin's... We could also then have the third coin be heads or tails. And then the same thing for these. Heads or tails off of each one of these. So you kind of see it's called a tree diagram. I mean, it doesn't just look like a tree, but that's the name they give this. But it just, again, just another systematic way of doing it. And notice we get the outcomes here. We've got heads, heads, heads. Just follow the branches, if you will, all the way through. Heads, heads, tails. They'll be in a little different order. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And last but not least, tails, tails, tails. So look at that. There's our list. Got 8 of them. Same list, a little different order, but there are 8 of them. But we'll use that to kind of help us with another part that we'll do here later on. So it's called a tree diagram. So if they asked you to do a tree diagram, that's the sort of thing they want you to do. Question or concern? Look okay? All right, so let's continue here. Number 3 on this part of what we're doing. All right, so number 3, let's see. How many possibilities are there if we roll a die? How many possibilities are there to roll a die? Now, you may not be as familiar with that term as you are with the term, the plural term there, dice. That die just means the singular of dice. Die is singular of dice. So we're just talking about one of the pieces in when you roll the dice. This is just saying let's roll one. And you know what I mean by dice, right? It's the number cube, 6 sides. Each side has different number of dots, right? 1 through 6. So how many possibilities? This one's an easy one. How many possibilities are there? Well, you got 1 through 6, right? You could roll a 1, 2, 3, 4, 5, or 6. So there's 6 possibilities, obviously. Now, how many possibilities are there if we roll a pair of dice? All right, well there's a few more there, so let's think about listing those out. This one we might do more with a table here. So let's say we've got, all right, so again, make a distinction between the dice, whatever colors you want to make them, or red and green, or so each one, the red one and the green one, there's 6 possibilities, right? 1 through 6. Okay, and I may not do the whole table here, but let's just think about it a little bit. I think we can get the number here without maybe doing the whole table, but you know, if we want to do the whole table, we can. But here's the possibilities, all right? So if I've got a green, that's 1, and then a red, that's 1. That roll is a 1, 1. So I've got a 1 on the green, 1 on the red. Then I got, for this next one, I've got a 1 on the green, 2 on the red, so I've got 1, 2. Then we've got 1 green, 2 red, 3 red, so that's 1, 3, 1, 4, 5, 1, 6. So kind of just list them kind of at pairs like that. One way we could do this. All right, then we've got the next row, right? 2 green, 1 red, so that'd be 2, 1, 2, 2, 2, 3, 2, 4. So it gets obviously quite repetitive, but 3, 1, etc., etc., etc. And then we'll not do the whole table because I said it's quite repetitive there. But yeah, what we'll wind up with, right, is 6 rows. We've got 6 rows and then 6 entries in each row there. So how many do we wind up total? 36. Yeah, 36. 36 outcomes. 36 outcomes. Now, one thing to point out again is this is like the coin thing, because notice this. 1, 2 is different than 2, 1. Those are 2 different entries, right? So those count each 1 time. So 1, 2, 2, 1. And the reason I say that is because here's the way they won't necessarily ask you how many outcomes are there when you roll 2 dice. They might. But so this would be, let's say 4A. All right, so 4A here. All right, so how many ways can we roll a sum of 8? Well, if you've got the whole table there, you can just count them up, but how many ways can we roll a sum of 8? Well, one possibility is, I guess the first one we come across is here, right? 2, 6. But there's other ways. 3, 5. 4, 4. Any others?
5, 3.
5, 3, yeah. Yeah, that's exactly what we were saying. If you reverse them, that's different. That's a different row because it's, 2 different dies. We're making a distinction there.
6 and 2.
6, 2, yeah. That's about it, isn't it?
Right.
Anything else, we can only go up to 6, so 7-1 is not a possibility because you can't roll 7 in one single die anyway. So yeah, anyway, just listing, so if it asks for a sum of whatever, just list them all out like that and count them up. We got 5 ways we can do that. Be aware of those little things like that. All right? So that's another thing we'll count up, or things like that. Okay? Another thing we'll do is we'll talk about counting numbers. How many 2-digit numbers are there using the digits 0 through 3, 0, 1, 2, 3. So how many 2-digit numbers are there using the digits 0, 1, 2, or 3? All right, so again, we're just doing this by listing. The first thing to point out here, I want a 2-digit number. And so that means a 2-digit number that doesn't reduce to be another number. Here's what I mean by that. I'm not going to start here with 0, 1. Because 0, 1 is technically just a 1-digit number, because the 0 in fact doesn't count as far as being a digit here. The 0 doesn't, we usually don't write that, right? Okay, so to be a 2-digit number, we need to start with something other than 0. So the first digit can't be 0. And we're talking 2-digit numbers. Now, the first digit can be 0 in some instances, just not when we're wanting 2-digit numbers or 3-digit numbers or how many ever digit numbers we want. 0 is not going to be the first digit. So the first one, if we go in order here, is going to be 10, right? All right, then the second point to make here is, unless it says you cannot use repetitions, or it doesn't imply that you can't use repetitions, you can do repetitions, okay? So you can do repetitions as long as it doesn't specify you can't. So another possibility is 11, and then 12, and then 13. And so here's my system. I'm just going to do the first digit 1, then I'm going to do the first digit 2, so I have 20, 21, 22, 23, and then I'm going to do the 30s, 30, 31, 32, and 33, okay? So there's 12 ways, 12 numbers. All right? Any questions about that?